Hello, here's the Group Dreams project presentation. Our topic is the primary productivity in Chatham rice in New Zealand. The most primary productivity growth in New Zealand's marine environment is phytoplankton. The growth of phytoplankton is affected by the nutrients in the sunlight. It is important to study the phytoplankton growth because it supports the marine organisms such as fish, mammals, and seabirds. This monthly data is recording the phytoplankton growth in oceanic waters around the Chatham Rise region from January 1998 to December 2017, measured in milligram per cubic. Our aim is to forecast the phytoplankton growth in the next 10 years. We create a time series plot and it shows a clear repeated pattern. We also found the trend is slightly moving down between 2010 and 2015. Next, we check the ACF and PACF for the original time series, and we can see the curve pattern in the ACF plot. Thus, the seasonality and existence of trend should be reasonably considered in this time series. To remove the seasonal trend effect, we fit the plan model with the first seasonal difference and check the residuals and autocorrelations. We found that the trend is removed, but in the plot ACF of residuals, it shows significant autocorrelations at leg 12 and weak autocorrelations at leg 24. In the PACF of residuals, both leg 12 and 24 are significantly outstanding. Therefore, the next step is fitting SAR2 and SMA2 with first seasonal difference on the plane model.
In model specification, we start with fitting the SAR2 and SMA2 with first differencing. And our SARIMA models look like this. After applying the log transformation and first differencing, the SARIMA model looks like this. Then we plot the ACF and PACF plots, and in the ACF we can see that there is one significant lag at lag 1, which indicates the MA1 model, and in PACF there are two significant lags at lag 1 and 2, which indicates the AR2 model, and our corresponding SARIMA models look like this. In the EACF table, we select the 3 points at the top left corner, and which indicates the ARIMA model as 01, ARMA 02, and ARMA 12. And our corresponding SARIMA models looks like this. So finally, we concluded our models to be this, and we added one more model just to overfit the two models.
Next step, we will fit those model above, whether it's white noise or not. SP6, 7, and 8 almost show the white noise. And the normality tests for them are all not normal. Consider data is large, we can read off it. After the comparison the ACF and the PACF, we find out the SP8 outperform SP6 and 7, with one leg in both PACF and ACF. But it close to the blue dashed line. Moreover, we fit the overfitting mode of SP8. SP9 looks the same as SP8, but we picked SP8 since it is smaller than SP9. Furthermore, a result of coefficient text shows AR1, AR2, MA1, SAR1, SMA2 are significant. Therefore, we should use mode SP8 sigma 211 times 112. Now I will pass to my teammate Kathy.
Okay, thanks Ted. This is Casey. Let's move on to the next stage to choose the most fitted model, SP10, for prediction. First of all, from the time series plot of the residual plot, we can see that seasonality is pretty much fitted out, since we can see ups and downs, but they look quite random, which means it doesn't really indicate seasonality. So we use ACF and PACF to determine the seasonal part. I believe that Ted has mentioned before. From the ACF and the PACF graph, we can see it is adequate for the model, and we can stop now for the seasonal part by no need for higher Q used. Meanwhile, when we compare the AIC, It also supports our idea since the AIC of SP10 has the smallest value. Hence, we use SP10 model to do the forecasting. There's a point needed to note here. Although from the QQ plot and the histogram of standardized residues, we can see that the data might not be normality. It is not quite important due to the large sample size we used. From the final graph of our presentation, we can see that in next 10 years, the productivity Chatham region will remain the same trend as previously. Yes, ups and downs, but overall, a slight rise. In conclusion, the data we used is collected for investigating phytoplankton growth in oceanic waters around the Chatham Rise region from January 1998 to December 2017 bi-monthly, and we use our fitted model to predict the growth in next 10 years. The result is it will have a slight increase in future years. The reason for the rise might be a result of a small potential climate change. Thanks for watching.